Hello, good morning everyone. Today we will start the next part of Work and Energy chapter class 9. Here we will do today the power part. We have already seen what is work, what is energy. Now we have to see what is power. Power can be defined as the rate of doing work. That means at what rate work is done. We can say work done by time taken is the formula for the power. For example, we have power we denote it by P and work done by time taken and work done by W and time by T, then power is equal to work done by time taken. Power is defined as the rate of doing work. At what rate a body is doing work. Or power can also be defined as the rate of consumption of energy. For example, if we talk the power of an electric bulb or any electrical appliance or an appliance, then power is equal to energy consumed by time taken. In that case, power we will denote by P and energy consumed by the body by E and the time taken by T, then the power is equal to energy consumed by T. That means power P is equal to E by T. Power, we will see the SI unit of power now. For work or energy, we have seen the SI unit is joule, and for time we have seen second. So the SI unit of power is joule per second, or we write in this way J per S or Js minus 1. And this Js minus 1 or joule per second is known as a watt. It is known as watt. W-A-T-T watt. So the SI unit of power is watt. The bigger units are kilowatt, megawatt. 1 kilowatt is equal to 1000 watt. 1 kilowatt. We denote it in short like this, kW is equal to 1000 watt. And this watt we write in just W. In the same way, 1 megawatt. M and W is equal to 10 to the power 6 watt. There is another unit also for power, that is horsepower. 1 horsepower is equal to 746 watt. But nowadays this unit is not used. Now we have, what is the meaning if we say that the power or of a body is 100 watt? What does it mean? Or how do we define 1 watt? 1 watt is defined in this way. When a body consumes 1 joule of energy in 1 second, then the power of that body is said to be 1 watt. Next is, what does it mean if we have an electric bulb written there 60 watt? 60 watt, when it is written on the electric bulb, it means that the bulb consumes energy at the rate of 60 joule per second. Because I told you that power is also equal to energy consumed by time taken. So if of an electric bulb, on an electric bulb it is written 60 watt, or nowadays we have got 10 watt or 5 watt one like that. It means that if it is written 5 watt, that means this bulb will consume 5 joules of energy per second. That's why now we have got nowadays, earlier we used to have that big one bulb, yellow color one, yellow one. Then came LED bulbs. Now we have got, no, not LED came. Then after that CFL came. And then nowadays we are using LED bulbs. These LED bulbs they consume much more electrical energy as compared to the previously used bulbs. So nowadays we are using this LED bulb, because you will see LED bulb 5 watt, 10 watt, 15 watt, and they give so much of light. Next we have the power of an electrical appliance. What does the power of an electrical appliance tells us? The power of an electrical appliance tells us the rate at which it consumes electrical energy. The rate at which it consumes electrical energy. Let us solve one numerical based on this formula. Suppose you are given a body does 50 joule a body does 50 joules of work. Question. Let us see. Suppose we take a question. A body does 50 joules of this side, yes, of work in 5 seconds. Full stop. What is its power? Question. So solution. How will we do that? See here. Power is equal to work done by time taken. Work done is 50. Time taken is 5 seconds. 5 ones are 5 tens are. That means 10 joules per second, and 10 joules per second we write watt. So power is equal to 10 watt. What will be the power? 10 watt. Now we can be given another numerical. For example, we may have of an electric bulb one, or electric any other electrical appliance. Okay, suppose we are given a question. Electric bulb consumes 7.2 kilojoule of electrical energy in 2 minutes. Question. And electrical bulb consumes 7.2 kilojoules of energy in 2 minutes. Full stop. What is its power? This is our question. So let me clean this part first. So what we are seeing in the solution, we will write. In the solution, we will write power is equal to energy consumed by time taken, and energy consumed is how much? 7.2 kilojoule, and time taken is how much? 2 minutes. And we have to convert each of them in the SI unit. So 7.2 into 1000 joule it became, and this one 2 into 60 second. Remove the decimal. 110 will come here. 1 0 1 2 0 1 0 2 0, and 6 12 are, and 2 5 are. That means 60 joule per second. So we say watt. So this is your answer. So what is the power? What is its power? It means what is the power of this electric bulb? So the power of this electric bulb is 60 watt. That means it will consume 60 joules of energy in 1 second. Next we have got many more numericals are there. You will solve them. Next we have commercial unit of electrical energy. What is the commercial unit of electrical energy? The commercial unit of electrical energy is kilowatt hour. Kilowatt hour. The commercial unit of electrical energy is kilowatt hour. What does it mean by saying kilowatt hour? Or how we have come, how do we define 1 kilowatt hour? That means if we have, see this joule per second or watt, these are what? These are smaller units. and electrical energy is consumed at such a high rate. So much electrical energy we consume in our house also. We use our electric bulb or fan or other electrical appliances for many hours. So if we are using it for so many hours, then what will happen? The electrical consumption will also be large, and if we measure it in terms of watt, it will be difficult for us or to write. We have to write bigger units. So what we have, instead of using watt, commercial electrical commercial unit or the unit for the commercial electric consumption is kilowatt hour, and this kilowatt hour we define in this way: when an electrical appliance will consume 1 kilowatt of energy in 1 hour, then we call it as kilowatt hour. If any electrical appliance or if any body which is using energy and it is consuming at the rate of 1 kilowatt hour, 1 kilowatt in 1 hour, then we will call it as 1 kilowatt hour. So we say in this way. Now the electricity is coming. Now in this way we will see that the commercial unit of this electric or the energy we are using as kilowatt hour. Commercial unit of energy is kilowatt hour. Now we have a relationship between kilowatt hour and joule. Kilowatt hour and joule. What is the relation? So 1 kilowatt hour is equal to 1 kilowatt into 1 hour, because I have already told you that when an electrical appliance consumes 1 kilowatt of energy in 1 hour, then the total energy consumption will be 1 kilowatt hour. So 1 kilowatt hour is equal to 1 kilowatt into 1 hour, and 1 kilowatt means 1000 watt, and 1 hour means 3600 seconds. So it will be 1000 joule per second, we can say, because watt is what? Joule per second. We have already seen joule per second as watt, and then it is 3600 joule. So 3600 second. So this 1 hour is 3600 seconds. Second cancelled. So we have got 36 and then 5 zeros is the joule. So we can write it as 3.6 into 10 to the power 6 joules. So this is the relation of between 1 kilowatt hour and joule. Again I am repeating, 1 kilowatt hour is equal to 1 kilowatt into 1 hour, because when 1 kilowatt of energy is consumed in 1 hour, so into we are doing, and here 1 kilowatt is 1000 watt, 1 hour means 3600 seconds, and this is, we write watt as joule per second, and this one written second cancel, and this you multiply, and this way we are writing. So it is 3.6 into 10 to the power 6 joules. Next we have numericals based on this. Suppose a family uses 200 units, or you say 250 units of electrical energy during the month. Calculate the electrical energy in joule. We are given that a family is using, let me clean the board. See, 1 kilowatt hour is known as 1 unit. In our house, when we are consuming electrical energy, and when the electrician or the person who does the measurement of our meter reading, he comes, he takes out the bill from our meter, he tells us that you have used so many units. Suppose they say 50 units, 5 units, 10 units, like that they tell us. Now, so what does they mean to say? 1 unit is equal to 1 kilowatt hour. So here one numerical is there. A family is using 250 units of electrical energy during a month. Calculate this electrical energy in joule. So what we will write? We will write in solution that 1 unit is equal to 1 kilowatt hour. So 250 units will be what? Is equal to 250 kilowatt hour. And we know 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Therefore, you write 250, or you write first that 1 kilowatt hour is equal to 3.6 into 10 to the power 6, 10 to the power 6 joules. Therefore, 250 kilowatt hour is equal to 250 into 3.6 into 10 to the power 6 joules. We remove this decimal, 10 will come here, this 10 cancel, then you multiply 36 into 25. 36 into 25 you multiply. Into 25 will multiply 180 plus 72 0 900 is coming. So what you do, you write here 900 and here 10 to the power 6 joules. So you can write a 9 into 10 to the power 8 joules. So this is the answer. In the electrical energy in joule will be 9 into 10 to the power 9 into 10 to the power 8 joules. Clear? Now next we have transformation of energy. That means energy is being transferred from one form to another form. For example, in the thermal power plant, what is happening? The steams are being produced. How? By heating the water. This coal is being burnt, and then the water is being heated. That water gets converted into a steam. That steam goes and rotates the turbine, and then there is the production of electrical energy. So what is there? The coal is being burnt. The coal is burnt, that is the stored chemical energy, we can say. We can say fossil fuels are, that coal is a fossil fuel. So there is the chemical energy is there, and that is being burnt. Heat energy is produced. That heat energy is boiling the water. Water gets converted into vapor. That means that vapor goes and moves the turbine, and then the turbine rotates, and then the electrical energy is consumed. Next we have in the hydroelectric power stations. There what we have, there behind the dams, what we have, so much of water is there. That water is allowed to fall from a height. So water has got potential energy that at the height. From that it is being allowed to fall on the big turbines. The turbines rotate. So potential energy gets converted into kinetic energy when the water is falling. And that the kinetic energy again turns the turbine. The turbine, you can say in the turbine, or if you say like this directly, that the potential energy of the water is rotating the turbine. So potential energy of the water gets converted into the kinetic energy of the turbine, and then the turbine, when it rotates, it produces electrical energy. So I have written few examples where we are doing the conversion of energy from one form to another form, and then I will let you know what are the different forms in which the energy is being converted. For example, in the case of electric motor, what is happening? In the case of electric motor, when we are using the motor, the electrical energy is being converted into mechanical energy. That when you are switching on the motor, for example, for pumping water, then the electrical energy is being supplied to the motor, and then motor, what it does, it takes the water from bottom to the into your tank. So we can say that the electrical energy is being converted into mechanical energy. Next we have got electric iron. In the iron, what is happening? When we are supplying electric current, to the electric iron, then it gets heated up and we are pressing our cloth. So electrical energy is being converted into heat energy. In the case of electric bulb, when we are switching on the bulb, electric energy gets converted into light and heat energy, because after some time when you touch, the bulb is heated. So we say less amount of heat is generated, more we get is light. So electrical energy gets converted into light energy and little amount of heat energy also. Next we have radio. In the radio, what is happening when we are supplying electrical energy? First, what is happening? Movement is there, mechanical energy we can say, and then there is, or you can say kinetic energy, because motion is there, and then it is getting converted into sound energy. Next we have a steam engine. In the steam engine, you all know we burn coal. When coal is burned, then what is happening? Heat is being generated. So in the coal, it is the chemical energy. Chemical energy is being converted into heat energy. That heat energy hits the water gets converted into steam, that steam goes to the shaft and then it rotates it, and then the engine moves, and along with the wagons or the bogies, all that move. So we can say in this way that in a steam engine, what is happening? The chemical energy is being converted into heat energy, and then again it is converted into kinetic energy, or the movement of the whole steam engine or the wagon and all. Next, in the car engine, what happened? Chemical energy is there. Fuels we are using, either diesel or petrol, whatever we are using, that fuel is having chemical energy, and that chemical energy, or if CNG car is there, gas one, there also chemical is there. Chemicals, they are burned. That chemical energy is getting converted into heat energy, and that heat energy is getting converted into mechanical energy. Next, we have cell or a battery. In the cell or a battery, cell we call single, and when a group of cells arrange or joined together in a series or parallel, we call it a battery. So cell or battery, both of them has got chemical in them. So when we use that cell or a battery, then the chemical energy is being converted into electrical energy. Next we have gas stove. Gas stove, we are using gas. In the gas, what is there? Chemical is there. Now the LPG, what is there? It is chemical is there. We are deriving from the petroleum, as a byproduct of petroleum refinery. We are doing refining is going on in the petroleum products. Then we are getting the LPG. That LPG is being used there in the cylinder. So when we are burning that LPG, then what is happening? Then chemical energy is getting converted into heat energy. Then we have solar water heater. In the solar water heater, what is happening? That solar energy of the sun is being converted into heat energy. In the solar cell, in the same way, solar energy is being converted into light energy or electrical energy. Next we have, if we are making use of the cell to burn a bulb, then finally we will get light energy. That's why I told solar energy is being converted into electrical energy, and finally we can say as the light energy, or we make of the solar cell to pump water also. So it will be, again, that solar energy will be converted into electrical energy. Then electrical energy is doing the work of pumping the water, so it is mechanical energy. But if we say only solar cell, then its solar cell converts only the solar energy into electrical energy. Now we have last part of this chapter, law of conservation of energy. What does this law of conservation of energy state? According to the law of conservation of energy, energy can neither be created nor can be destroyed. It can be changed from one form to another form. As we have seen so many examples here, that what is happening? One form of energy is being getting converted into other form of energy. Achha, one more thing is there given here, that the conservation of energy during a free fall of a body. That how we know that the conservation of energy takes place. We have studied just now that according to the law of conservation of energy, energy can neither be created nor can be destroyed. It can be changed only from one form to another form. So during a free fall of a ball or any object which is falling from a height, and what we will see, suppose a ball is falling from this place at this point, and it will reach finally this ground level over here. Then at this place, at the highest point, or from where I am dropping, it will have the maximum potential energy. Potential energy will be there. Okay, and kinetic energy will be 0 at this point. Slowly, when I will drop it, then after dropping, what will happen? Some amount of the potential energy will get converted into kinetic energy. So it will have what? It will have both potential energy as well as kinetic energy. And similarly, it will go on potential energy, kinetic energy, potential energy. Both will be there. In the middle state, we can say it will have both more or less equal amount of potential energy will be there and the kinetic energy will be there. Then after that, when it will be close to this surface where it is about to reach, then what is happening? The potential energy is decreasing. Why? Because the height is decreasing. The potential energy will keep on decreasing because the height will keep on decreasing. And then the kinetic energy will keep on increasing. Why it will keep on increasing? Because the velocity will keep on increasing. Here the velocity was 0, then it became something and so on like that. And at this point where it will strike at this place, suppose this is the surface of the ground, then what will happen? Here the potential energy will be 0 and maximum kinetic energy will be there. So potential energy is being converted into kinetic energy. In the middle we saw both of us there, potential energy as well as kinetic energy. So this is what we can say, that free fall of a body, potential energy, kinetic energy getting converted into kinetic energy, and in the middle part we have both of them. Thus in this way we can say that energy can neither be created nor can be destroyed. It can be changed from one form to another form. And then the conservation of energy takes place during a free fall. Next we have conservation of energy in a simple pendulum. When we see the case of a simple pendulum, suppose we have a simple pendulum. Then here this level we take here. This is the circle. Then when the pendulum will go, it will go this place. This side it will go this place. Here at this place, these are the extreme positions we can say of this pendulum, and this one we can say the mean position, here middle one. So when this pendulum is at this position, suppose I take this one level as the middle point, mean point, here we are taking. Then in this case what will happen? This pendulum, it will have central position and only there will be kinetic energy. Only it will have kinetic energy. In this central position, this pendulum will have only kinetic energy. When it will go this side, what will happen? Its kinetic energy will keep on decreasing, and then a position will come here when its kinetic energy will become 0 and it will have maximum potential energy. And then again from here it will keep on moving this way. Slowly it will come this side, and here it will come, and this place at the next extreme position, there we can see that there will be again only the potential energy. So this extreme positions we will see it will have potential energy, and in the middle it will have kinetic energy. But in between these two we will see both will be there, that means kinetic energy as well as potential energy. In this position also we will see both will be there, kinetic energy as well as potential energy. Thus what we are saying, that one form of the energy is being converted into another form. See actually, suppose we will tie a ball only to a thread, and then we will take the ball up to this position, and this is my table level. Then it will have certain height, this height. So because of that it will have potential energy. I will take the ball, I will catch it here, and then I will leave from here. And what will happen? The potential energy will get converted into kinetic energy, maximum kinetic energy here, and then it will keep on going and it will decrease, and again from here it will, and this way this process goes on, and thus we can say that the potential energy gets converted into kinetic energy and the kinetic energy gets converted into potential energy. Thus we can say that in the case of a simple pendulum, consumption or conservation of energy takes place. Energy is neither created nor destroyed. Only what is happening, one form of the energy, potential energy, is being converted into kinetic energy, and the kinetic energy is being converted into potential energy. Now this chapter is over. Okay.